Okay, so first let's review slope. Slope is just change in y over change in x. Okay, so we know the slope formula for a line, right? But when you're along that line, once you find the slope of that line, or any point on that line, it's going to be the same slope all the way through. But we're going to be exploring this concept of slope when we reach the second unit, because now all of a sudden we're going to be dealing with curves that don't have a common slope, but we're still going to be able to create a formula that will tell us every point on that curve. And we're going to use that, we're going to build that concept off of the slope formula. But right now we're just reviewing some algebra skills here. Okay, so slope we know is change in y over change in x. Okay, linear equations. If I want to find equation for a line, there's two ways I can go about doing it. I can, if I have an ordered pair and a slope, I can put it into point slope form. Now, point slope form is going to be the form that is preferred in our course. We can always get a linear equation into slope-intercept form, and this feels more complete, simplified, because we're just used to slope-intercept form. But I'm going to encourage us to stay in point slope form because one, it's faster to get there. If I have a slope and order pair, that's usually our entry into equation of a line. We get the point, we get the slope, and we put it in point slope form. I'm going to try to encourage us over the course of the school year to leave our answer in point slope form. Okay? It's not wrong if you distribute and clean up and get into slope intercept form. But on the AP exam, if they ask you for equation of line, they will accept this form. And the reason why we prefer this form is because first, it's faster to get to. Okay, and second, if you make a mistake somehow getting from here to here, then you would potentially lose some credit. So, you know, why not just leave our answer in the form that they will accept and arrive there faster. But that's going to take some time to get used to because we're used to slope-intercept form. So if you ever work a problem and you're trying to clean up and you get to slope-intercept form, that's perfectly fine. You won't lose any points for that. But the suggestion is that that we want to leave it in point slope form. Why, you know, continue working on the problem when it's already complete. Okay, so next up, parallel lines. Parallel lines have slopes that are equal. So now, having said that about point slope form, the nice thing about slope intercept form is that it is a quick way for us to get the slope information about a line. If I can solve for y, then that m value is that coefficient in front of the x is always going to be your slope. So even though point slope form is the preferred method, sometimes slope intercept form is the quicker way to get the information that we want. Okay, perpendicular lines. These are lines where they intersect at a 90-degree angle. And the relationship between perpendicular lines is that their slopes numerically have this relationship with each other, and that they are opposite reciprocals of each other. Okay, so an example would be this. If the slope of one line is 3, then what is the slope of a second line that will be perpendicular to that first line? -1/3. So we take that 3, which is 3 over 1, and we flip it, and we change the sign. So it's two things that needs to go, that needs to happen. We're going to flip that number and change the sign, and then those two slopes are now going to be perpendicular to each other. Okay, vertical lines. Vertical lines have this form. it's always x equals a number. This looks like just solving for an equation and solving for x, right? But this is actually the equation of a vertical line. So for instance, if I were to draw a vertical line down and let it cross the x-intercept of 3, think about the collection of all these points. Every point on this line has an x value of what? X value of 3. So that's why it's x equals 3, because if I accumulate it, every order pair that has an x value of 3, that's the shape, that's the graph that's going to show up, a vertical line. A horizontal line is going to have a form of y equals a number. So for instance, if I want to graph y equals 5, I find the y-intercept of 5, and I draw a horizontal line through it. And the relationship here is that every single order pair that I have showing has a y value of 5, and that is why a horizontal line has y equals 5. Now, this may be a little counterintuitive because we associate horizontal with x, and we associate vertical with y axis. But as far as equation of lines, vertical line is x equals number, horizontal line is y equals number. Okay, solving inequalities. All right, so I'm going to go through this step by step here. The first step is when we deal with inequalities, we're going to first write our problem as an equation. The reason why is because then we can get the information that we need, which is critical values. We're going to find critical values by setting both the numerator and the denominator equal to 0. Now, when we're looking for a solution for an inequality, it's not just going to be a number, right? It's going to be a range of numbers. We want to find all the values where x plus 5 over x plus 3 is less than x plus 1 over x minus 1. It'll be a range of values. So we're going to find critical numbers to help us figure out where the different where the separation is for each interval. And then we'll make a sign line, test the critical points, and then we can test the values on the sign line using the inequality and find the interval for our solution. Okay. This is a little bit long here, so I'm going to put this on a separate sheet. So example 1. Okay, so first thing I'm going to do is I'm going to get this as an equation. I'll come back and worry about the inequality later, but my focus is trying to get my critical point. All right, I'm going to bring everything over to one side, set equal to 0. I find that's easier to find critical points that way. Okay, so I'm going to subtract this right side over to the left. Okay, so next thing is I'm going to find common denominator, right? Anytime I'm subtracting or adding fractions, I can't merge the fractions unless I have the common denominator. So common denominator, x plus 3 and x minus 1, those are completely separate expressions. So we need both of them to create my common denominator. So my common denominator is going to be x plus 3 and x minus 1. So I'm going to create both fractions with that as my common denominator. I need something large enough that both individual denominators can go into safely. Okay, so now we need to balance each of the numerators. We got to ask ourselves, what changes occurred between this first denominator and this new denominator? What's been added? X minus 1, right? So because we needed an x minus 1 to get to the new denominator, I need to do that to the numerator as well. So whatever I do to the denominator, I need to also balance out with the numerator. So I need to multiply the numerator then by x minus 1. Okay, let's observe the second old denominator. What's changed between here and here? X plus 3. So I need to balance the second numerator with an x plus 3. Okay, now that I have common denominators, I can merge the fraction together. Okay, what we don't want to do is we don't want to start canceling out, because if we start canceling out, we're back to where we came from. Okay, we're trying to make progress here. We're trying to merge the fractions together. So next step, I'm going to FOIL the numerators out so that I can merge the fraction together. I'm going to leave the denominator alone, but I'm going to spend the time to try to merge the numerators together. So I'm going to FOIL each of the numerators out. Little by little, I'm going to combine all the I'm going to clean things up here. Notice that I've merged the two fractions together. They all share the same denominator. I've balanced the numerators out. Now, why did I put a new set of parentheses over here? Say it again. Right. This negative, we got to be careful here. This negative is going to impact everything that comes after it. So I just prep myself as a reminder. Okay. My next step, I can drop the parentheses, but I'm going to remember to distribute the negative through every term. Combine some more like terms here. The x squared goes away. 4x's goes away. Like term, I'm left with -8. Okay, so this is the results of this whole mess right here. Right? I'm able to merge these fractions together, clean it up, but now I'm setting it equal to 0. Okay. Now we're not doing this to find the solution. We're doing this to find the critical values that will help us find the solution, because we know it's going to be a range of values on a number line, but we need some separation on that number line. So the next step here is find critical values by setting both the numerator and the denominator equal to 0 separately. Okay, so we're going to find critical numbers from both locations. Now, the numerator equal to 0 is not going to produce anything for us. There's no variables. -8 equals 0 doesn't make sense. But the denominator, x plus 3 and x minus 1 equal to 0, we have some x's there, so we have some critical values. So what x values will come out of the denominator? Okay, -3 and 1. Now, these are the values that's going to go on the number line. Okay, and these are the values that's going to help separate the intervals that we're looking at. So next step, make a sign line, make a number line involving the critical values. Now, these critical values are coming from the denominator. If a critical value is coming from the denominator, these critical values will cause the expression to become undefined. So imagine inserting -3 back into the original inequality. -3 plus 3 is 0. You can't have 0 in the denominator. If I insert 1 into the original inequality, 1 minus 1 is 0. 0 can't be in the denominator. So what that means is that these will never be part of our solution set. We'll put open circles to indicate that we're going to be testing the intervals around them, But once we reach these critical points, we're gonna have to make sure we don't include them in our solution set. Nothing from the denominator can ever be part of our solution, but we do put them on our sign line as a way of separating our intervals. Okay, so now we're gonna test each interval. Now, the nice thing here is that everything in each interval is going to be a consistent solution. So everything here is either going to be all true or all false. Everything in the second interval will either all be true or all be false. Everything in the third interval is either all true or all false. So that means we can test any number in each interval, and if that number gives us information, we can make that conclusion for the entire interval. So give me a number that I can test to the left of -3.
-4.
Okay, -4, right? Typically, the smaller the number, the easier we'll have. So we're going to insert into the original inequality and see if it gives us a true statement. Okay? Because if -4 gives us a true statement, we're going to keep that interval. But if it gives us a false statement, we're going to exit out. We know that's not part of our solution set. Okay, so I'm going to test -4. Okay, I get. Okay, so I get -1 is less than 3/8. Is that a true statement? Yes, so we're going to keep that interval. I'm going to go ahead and highlight that. I know that's part of my solution set here. Okay, second interval. What's the number that I can test here? Between -3 and 1. 0. Okay, and this is also we're going to test intervals from a calculus perspective down the line. There's just a tip. Anytime you can involve 0, use 0 because 0 is usually easier to plug in. Okay, 5/3 is less than -1. Is that true?
No.
Yeah, false, right? So if it's false, we know that the second interval is not part of our solution. We can ignore it. Let's move on to the third interval. Okay, pick a number to the right of 1, 2. Seven-fifths is less than 3. Well, 7/5 is slightly greater than 1, but it's definitely less than 3. So that's a true statement. We're going to keep that third interval. So there we have it. We have our solution set. It's the left interval and the right interval, but not the middle one. Okay, let's put this in interval notation. A way of saying x is less than -3 is to say -infinity to -3. Notice there's an open circle there, so we'll leave that as a parentheses. Union or comma, we're going to skip an interval and arrive at the next one. Now, notice that I did not include the test numbers in my interval. Right? The test number is just to make sure whether the entire interval is true or false. But once we test those numbers, we don't include them in our interval. We go back to what we have initially on our sign line. So we don't. So whatever number we test, those numbers will not show up in your solution set. Okay. Any questions? Yeah. Oh, I'm sorry.
Yeah, it sounds like.
My bad, my bad. I was looking at some other numbers here. -3 over -5, which reduced to be 3/5. -1 was less than 3/5, so that's why we keep it. Sorry. Okay, any questions? Okay, I really want us to be able to make progress in our assignment. So let's see if we can finish up the assignment for P1 and be able to do a little bit from P2, because P2 has a lot of the linear finding equations of lines, and I want us to practice that. So So I'd like for us to see if we can finish up P1. So this is page 8 and 9. Again, if you don't have a notebook with fresh paper, we can always grab printer paper or loose leaf paper from my shelf there next to the door. But I think we made good progress yesterday, being able to at least get through hopefully the first 2 or 3 problems. And then as a reminder, for 23, anytime you're looking for x-intercept and you have a fraction to deal with, x-intercept, you're just going to set the numerator equal to 0. You're not going to worry about the denominator. If you set the denominator equal to 0, that's something else. That's the whole or asymptote. Yes. Oh, yes, yeah. So I'll talk to you about that. But see if you guys can make some progress, and then I'll show the other answers for the problems that you may have done. Okay, sorry, the 16 and 17 is my page number, but you want to look at the page number in the book, so it's going to be P2, so it's actually going to be page 13. Thank you. That's fine, that's fine. Okay, so if you did that now, guys, just for this week, I am going to check homework, but I'm going to wait till Monday to check the 3 homework. But if you're done with P1, then great. Go ahead and move on to P2. I am going to show the answer for this to make sure that you guys don't have any questions. Okay. But I'm hoping that we can kind of tackle little by little with the second half of class, so that if there's any homework you want to do too much before I check on Monday. So if you really want to keep that denominator, you can. You basically are setting you're replacing y with 0, right? That's what you're doing. But if I'm dealing with a fraction, put it over 1 so that I can match the fraction on the other side.
Oh, and you could explain.
And then if I cross multiply, I can convince myself that it's just the numerator that I'm worried about, because the denominator is going to multiply to 0.
Okay, thank you.
So I put all the textbook problems. I think that's so chapter 3, first page 9. Also, and the very last page is So get it into a slope intercept form. Yeah, y goes to x plus b, and then your m is your slope, and then your b is your y-intercept. Yeah, so sketch it out. Yes, that's right, yeah. Solve for y first, and then you'll be able to pull the slope and your y-intercept. Okay, if you're stuck on P2 assignment problems, hang on a minute. I'll make my way to those problems, but I want to make sure that P1 that we're good. So hopefully you found 25 to be pretty easy, because really if you just replace one variable with 0 or the other with 0, you can find the x and y intercepts pretty quickly. And then 57 through 62 is just practicing those problems that we did yesterday, right? Where you're solving for one variable, inserting into the other equation, and then solving for that variable, and then finding your intersection. Now, you may have chosen a different variable to solve than mine, which is fine, because for these problems, there are more than one easy variable to isolate. So your steps may look different from mine, but your points of intersection should be consistent with my answer. So 57 and 57 to 59. Any questions there? So find x-intercepts, find y-intercept. Find x-intercept, you replace y with 0, which is solve for x. Find y-intercept.
So I just have to use this as
Or for most of them, yeah. Take one of the past. Okay, 59 and 61. Now I'm going to solve for x. So 0 equals 2 minus root x. What if I just got root x on the other side?
So separate the right side.
And now I can square both sides to get x plus square. any questions from P1? So now moving on to P2, you got to flip over to the next printed photocopy sheet. Go to P2, which is page 16, 17, and I'm going to start working through these problems here. Find the slope and the y-intercept. The easiest way to find slope and y-intercept, I feel, if you're given an equation, is get into slope-intercept form. Because if I can get in slope-intercept form, then whatever number is in front of my x is the slope, and whatever the constant is going to be my y-intercept. Same thing for sketching a graph. If you want to sketch a graph, slope-intercept form is the quickest way, because if I can find my y-intercept and my slope, I can plot that point, and then I can reach the second point using my slope information. Okay, for number 40, if I want to find the equation of a line, if I can find a slope, then I can do point slope. Right? Choose either point, find the slope, and then put into point slope form and write the equation of the line. Now, if I want to find the equation of a line, the slope is going to be the same. But initially, you can choose either point. You can choose -2, or I can choose 1, 7. Either way, it's going to take me to the same equation. It may look a little different, but we don't have to go as far as slope-intercept form. So if you choose 1, 7, your equation may look a little different. But if we were to clean it up, it'll all be the same. So either is fine. I just want to show the different options in case your answer doesn't look like mine. So either one is fine. Okay, any questions up to 40? Yeah, sure. So if I'm given 2 points, I can find the slope. So change in y over change in x, 0 minus 8 over 5 minus 2, that's -8/3. Now, if I have slope, I can use either order pair to get into point slope form, right? So here, my point is 2/8. My slope, m is -8/3. And I can just put it in point slope form. I'm replacing m with -8/3. And I'm replacing x1 and y1 with order pair 2/8. But if you decide to choose another point, then your equation may look a little different, but it's the same. They just don't look the same because they're not expanded out and cleaned up. So if it was a quiz or test, you'd have to provide both answers. Either one will do. Any questions there? Okay, how do you go about graphing it? Okay, so you can choose either points. Let's say I want to use 5, 0 as my order pair, just fine. And now my order pair is 5, 0. I could have chosen 2/8. I just decided 5, 0 is easier to plot. And now, okay, technically I don't even have to have the slope because I can just plot 2/8. And just connect a line between those 2 points. But it's the same thing as plotting 5, 0 and then going down 8 and over 3. It's going to still fall along that line. Okay, 55. So I want a line to go through -7, -2, and I want that line to be parallel to x equals 1. Now, I think the easiest way to do this is to just sketch the graph out. So here's -7, -2. And x equals 1 is a vertical line that goes through the x-intercept of 1. So how can I create a line that's parallel to this line, but going through this point?
X equals -7.
It's just a vertical line that goes through that point. And then we know a vertical line has the equation of x equals, so this is just x equals -7. The second part is saying, what if I want that, what if we want a line that goes through this point, but is perpendicular to the second line? Make it what?
Y equals -2.
Make it horizontal. Okay, 59. We want a graph that goes through the points 2, 1. Okay, same strategy here. All we need is to find order pair and slope. Well, the order pair is already given to us, so that's easy. But this feels more complicated because what do we do with this? Well, if I can find the slope of this line, then I can use the same slope because I know it's going to be parallel to it. So all I need to do is to find the slope from this information. So all I care about this, all this messiness here is I should want to find the slope. So the easiest way to get to the slope, let's get into point slope form. Sorry, slope intercept form. And we can just pull the m value from that. So -2y is equal to -4x plus 3. If I divide everything by -2, okay, what's my slope? 2. And that's all I care about. I don't care about anything else from this information except that my slope is 2. Now I can move forward because part A, I just want something that has order, that will have order pair 2, 1, a slope of 2, and I can just put in the point slope form. I'm going to keep this slope 2 because parallel means same slope. So whatever the slope of this line is going to keep, I'm going to keep that same slope value. Part B is an extension. Part B, I want a point, a line that goes through 2, 1, but is what? Perpendicular. Oh, sorry guys, I went over. At least we got through a lot of the homework. Tomorrow, we'll continue with chapter P. Sorry, last bracket time. Thank you.
That's been good. Yeah, I'll try, you know.
Thank you for your.
Thanks.
Oh, I got my mom here.
Bye guys. Have a great day.
Beautiful time.
I get a calendar.
Oh, yeah. Appreciate it. Thank you. Thank you. Good day. Good day. Hello.